Today we are going to see the Z and Y parameters for the two-port network. The objectives for today's session are to analyze two-port network parameters. Basically in this session we are going to see the Z and Y parameters for the two-port network. Now let us see what do you mean by a port. A pair of terminals at which an electrical signal may enter or leave a network is called as a port. What do you mean by one port network? A network having only one pair of terminals or one port is called as a one port network. What do you mean by a two port network? A network consisting two pair of terminals is called as a two port network. Now let us see what do you mean by Z parameters or open circuit parameters. Z parameters are also called as open circuit parameters or open circuit impedance parameters. In Z parameters, V1 is a function of current I1 and I2. V2 is a function of current I1 and I2. So basically V1 is the voltage at port 1, I1 is a current entering port 1, V2 is the voltage at port 2 and I2 is the current entering the port 2. Now, in equation form, we can write this relations as V1 is equal to Z11 into I1 plus Z12 into I2. V2 is equal to Z21 into I1 plus Z22 into I2. In matrix form, we can write this as V1 V2 is equal to, I am reading the 2 by 2 matrix, that is the impedance matrix row wise. So Z11, Z12, Z21, Z22 into I1, I2. So basically we can say V is equal to Z into I. Voltage is equal to impedance into current. Now we are calculating the parameters when port 2 is open. So when port 2 is open, I2 is equal to 0. So I2 is equal to suggest that port 2 is open circuited. So V1 will now be Z11 into I1, that is Z11 is equal to V1 upon I1. V2 is equal to Z21 into I1 as we are putting I2 0. So Z21 is equal to V2 upon I1. Let I1 is equal to 0. Now I1 is equal to 0, we will say that the parameters when port 1 is open. So port 1 is open means I1 is 0. Again the two equations which we have written in equation form, in that equation put I1 is equal to 0. So we will get V1 is equal to Z12 into I2, that is Z12 is equal to V1 upon I2. V2 is equal to Z22 into I2. Z22 is equal to V2 upon I2. So let's see what do you mean by Z11, Z21, Z12 and Z22. So Z11 is called open circuit driving point input impedance. The parameter Z21 is called open circuit forward transfer impedance. Z12 is called open circuit reverse transfer impedance. Z22 is called open circuit driving point output impedance. So all this nomenclatures and formulas which we have seen, you should remember all this for solving the numerical based on this. So find the Z parameters for the network shown. The network is shown to you. We are supposed to find the Z parameters for the given network. So V1 is the voltage at port 1, I1 is the current entering port 1, V2 is the voltage at port 2, I2 is the current entering port 2, and basically a simple T network is given to us which is having 10 ohm and 15 ohm in series arm and 5 ohm in parallel arm. So now how to analyze? Let's try and analyze it step by step. First we will make I2 0 and write the equations. Then we will make I1 0 and write the equations. So by definition, again I am going to revise the concept so that it will be easy for you to correlate. By definition, Z parameters are given as V1 is equal to Z11 I1 plus Z12 I2, V2 is equal to Z21 I1 plus Z22 I2. As I said, we will first make I2 0, that is port 2 is open circuited. If port 2 is open circuited, we are supposed to apply KVL only to the loop which is present on left hand side, because if I2 is 0, no current will flow through 15 ohm resistor. So applying KVL to the left hand side loop, we are getting equation minus 10 I1 minus 5 I1 plus V1 is equal to 0. So V1 is coming out to be 15 I1, and we know by definition Z11 is V1 upon I1, that is Z11 is 15 ohm. Again, from this we can say, from the equation in the loop, we can say, see, if I2 is 0, what will be voltage V2? It will be same as the voltage across 5 ohm resistor. So can I say V2 is equal to 5I1? And if V2 is equal to 5I1, Z21 is V2 upon I1, that is 5 ohm in this case. Now, these are the parameters when port 2 is open, that is I2 is equal to 0. Let's try and write the parameter when port 1 is open circuited. Again, deliberately I have written here the equations so that you can understand them and correlate them while solving the numerical. Now, if port 1 is open circuited, what I am saying, port 1 is open circuited, I1 is 0. Therefore, applying KVL to the right hand loop, we are applying KVL to the right hand loop. I1 is 0, so no current will flow through 10 ohm resistor. Applying KVL to the right hand loop, we are getting the equation to be minus 15 I2 minus 5 I2 plus V2 is equal to 0. That is V2 is equal to 20 I2. Therefore, Z22 is V2 upon I2. Therefore, Z22 is 20 ohm. Similarly, as no current is flowing through the 10 ohm resistor, can I say V1 is equal to 5 I2? Yes. So if V1 is equal to 5 I2, Z12 is V1 upon I2, that is Z12 is equal to 5 ohms in this case. Therefore, we have analyzed the Z parameters. So now what we have seen in this video, we have seen that all the parameters which we have theoretically calculated, they are also solved practically. So practically we are calculating the values of voltages and currents and finding out the different parameters. So this video was a practical proof through the theoretical part which we have seen. Now let us see the Y parameters of the two-port network. This Y parameters are also called as short circuit admittance parameter. I1 and I2 are the functions of V1 and V2. Again, you know V1 is the voltage at port 1, V2 is the voltage at port 2, I1 is the current entering port 1 and I2 is the current entering port 2. We can write this above things in equation form as I1 is equal to Y11 V1 plus Y12 V2, I2 is equal to Y21 V1 plus Y22 V2. In matrix form, the above equations can be written as I1 I2 is equal to Y11 Y12 Y21 Y22 into V1 V2, that is I is equal to Y into V. Now let us see how to calculate this different Y parameters. So parameters when port 2 is short circuited. Let V2 is equal to 0. If we want to short circuit, then we are supposed to make voltage 0. If we want to open circuit, then we are supposed to make current 0. So as we are short circuiting port 2, that means we are making V2 0. If we are making V2 0, then the equations which we have written, we are getting I1 is equal to Y11 V1, that is Y11 is I1 upon V1, I2 is equal to Y21 V1, that is Y21 is equal to I2 upon V1. Parameters when port 1 is short circuited. So when port 1 is short circuited, V1 will be 0. So V1 is 0 means I1 will now become Y12 V2. Y12 is equal to I1 upon V2. I2 will now become Y22 V2. Y22 is equal to I2 upon V2. So nomenclature, the parameter Y11 is called short circuit driving point input impedance. The parameter Y21 is called short circuit forward transfer admittance. The parameter Y12 is called short circuit reverse transfer admittance. The parameter Y22 is called short circuit driving point output admittance. Why short circuit? Because we are shorting port 2 and we are shorting port 1. So that's why these parameters are short circuit parameters. Now the question is, let's find the Y parameters for the network shown. Again, if we are supposed to calculate Y parameters, first we will short port 2, that is V20, then we will short port 1, that is V10. Let's start by shorting port 2. So I am again revising what are Y parameters. By definition, Y parameters are given by I1 is equal to Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. Let V2 is equal to 0. That is, port 2 is short circuited. Now if port 2 is short circuited, we are applying KVL to the right hand side loop first of all. So what we will get? Minus 10 I1 minus 5 I1 minus 5 I2 plus V1 is equal to 0. See, all of you are familiar with writing the equations. Just the thing is, you need to correlate it with the shorting process, that is making V2 0. So in this case, I can club minus 10 I1 minus 5 I1 and I will get the equation 1 as minus 15 I1 minus 5 I2 plus V1 is equal to 0. This is equation 1. Now if you will see, when the port 2 is shorted, can I write the equation for current I2 when the input current is I1? I can very well write it using current division rule. So according to current division rule, I2 is equal to minus I1 into 5 upon 20. The negative sign exists because the direction of I1 and I2 are opposite to each other. 5 by 20 is 1 by 4, 1 by 4 is 0.25. Therefore, equation 2 becomes I2 is equal to minus I1 into 0.25. Putting equation 2 in 1. See, equation 1 was in terms of I1, I2 and V1, 3 variable. So what I am doing, I am putting 2 in equation 1 and I am eliminating I2. So what I am getting now, minus 15 I1 plus 1.25 I1 plus V1 is equal to 0. Combining the terms of I1 minus 13.75 I1 plus V1 is equal to 0. So Y11, which is I1 upon V1, is 0.072. Now, if we are putting equation 2 in equation 1, what again I am getting? Now see, what I did for this case, what I did for the first replacement, I substituted the value of I2 in terms of I1 and I got Y11. Now again I am putting 2 in 1 and now I am eliminating I1. So I am obtaining the KVL equation in terms of I2 and V1. So 60 I2 minus 5 I2 plus V1 is 0. 55 I2 plus V1 is equal to 0. So Y21 is I2 upon V1, that is equal to minus 0.018. Again, by definition, the y parameters are given. Why deliberately I am including it? Because so that you get the idea what are y parameters and what we are supposed to calculate. Now the process of shorting port 2 is completed. Now we will short port 1. So if port 1 is shorted, V1 is 0. Now we will apply KVL at the input side, that is to the right side loop. If I apply KVL to the right side loop, the equation that I will obtain is minus 5I1 minus 5I2 minus 15I2 plus V2 is equal to 0. Again, I am combining I2 terms, so minus 5I1 minus 20I2 plus V2 is equal to 0, calling this as equation 3. I will now write the current division rule for I1 in terms of I2. So now the equation for I1 in terms of I2 is I1 is equal to minus I2 into 5 upon 15. 5 upon 15 is 1 by 3. 1 by 3 is 0.33. That is what we are obtaining in this case. I1 is equal to minus I2 into 0.33. This is equation 4. So now I am again putting this equation 4 in equation 3. So what I will obtain when I am putting this equation 4 in equation 3? See, first I will replace I1 by I2. That means equation will be in terms of V2 I2. So putting I1 in place of I1, I2, I am getting minus 18.35 I2 plus V2 is equal to 0. That is Y22 is equal to I2 upon V2, which is equal to 0.054. Again we are putting 4 in equation 3. Now we are eliminating I1 and only keeping the terms of what? We are only keeping the terms of I2. So what we are obtaining now in this case? We are getting Y21 is equal to I1 upon V2. So what is the value that we are getting in this case? It is minus 0.018. So now we have obtained Y22 and also we have obtained the value of Y21. So in today's session, we have analyzed the Z and Y parameters for two-port network. Are these concepts clear to you? We have seen the Z and Y parameters for the two-port network. The Z parameters are called as open circuit parameters. The Y parameters are called as short circuit parameters.